Hello everyone. Firstly, let me introduce the Wenchuan earthquake happened in 2008 in China. It's a very huge earthquake and it caused a lot of economic losses and people's deaths. It influenced China greatly, and it had led to several seismic codes changes and for example, the performance-based design has been introduced in the new codes since 2010. So, firstly, when earthquake it happened at this time, and as this picture shows, a lot of buildings collapse and some walls are destroyed, especially the corner wall. And because for a structure, it has some rotation response, and the corner wall and corner columns will influence large displacement and large damage. There is obvious X between two windows. X cracks. It is because in the deformation between two windows, there is just like a shear deformation. And it is obvious between the top and below, okay? And the two windows is also an obvious X crack. The corner wall is severely damaged. This picture is shown. It's showing shows a beam between two walls. We call it it's energy dissipating beam. Okay, it's usually designed to dissipate energy and coordinate to walls forces and displacements. In the earthquake, the beam is firstly is the first components to be damaged, to be plastically deformed. It is factory, and the bracing is damaged, and all the buildings collapse. As earthquake happens with uncertainty, we don't know when earthquake happens. We don't know the happens time histories. We know the amplitude. We don't know. We don't know the amplitude. We don't know the frequency contents of the earthquake excitation, and we also don't know the duration. So even on the same site, even two buildings are close, they may experience different excitations. It depends on the earthquake vibration transition. It also depends on the soil. Okay, on which type of soil the building is constructed on. And as this picture shows, this building there is little damage between windows, but in the adjacent building collapse. Okay, collapse. It's the same. Okay, the building stand on and the building collapse. This is a school. Okay, this is a school. If there is a rotation, because for this structure type, the mass is merely on this side, okay, but the stiffness, okay, is even. The stiffness is even. So the initial force and the resisting force is not is not on the same line. Okay, it's not on the same line, so it will produce the rotation, and the rotation will produce severe damage of the structure. Fabricated, okay, fabricated floor, okay, our floor, okay, falls down or is damaged. It's very dangerous. Okay, fabricated construction is popular now in China because governments want to promote the whole process of prefabricated construction. However, there's still some problems, such as the joint, okay, the fabricated joint. We must ensure the joint is as strong as the original at the Euro structure, okay, at the Euro structure. But how? Okay, so if there is not appropriated connection, appropriated fabricated joints, the joint may be the first component to be damaged in the earthquake. Nowadays, some concepts were also proposed, such as if we make sure the fabricated joint is strong enough to be stay elastic on the earthquake, so the other parts will deform and damage, and plus plastic hinges will form, okay, in other parts. So we can protect the fabricated joints and utilizing other parts to absorb the seismic energy. It may be another strategy more safer than Euro concepts, okay. And this car by the falling walls, okay, damaged. The whole floor, okay, the whole floor is damaged, and obviously there exists a plastic hinge on the column, okay. We usually design a structure to ensure the first hinge emerge in the beam, okay, because the column is an important component to support the whole gravity of structure. If the column from plastic hinges, it is usually to cause collapse of whole structure. So actually, it is assumed to be plastic hinge on the beam, or not on the column. Okay, so however, in practical structure and recorded earthquake damage structures, we notice that some plastic hinges emerge on the column, okay, on the column, because the floor can provide additional stiffness to the beam, okay, and to make the beam stronger, okay. So in the design, it is reasonable to consider this effect of the floor's constraints and floor's stiff effect, okay. And it also, we can notice the plastic hinge emerge on the joint is very dangerous, actually. Emerge on the column, okay, on the column. Also on the column. Okay, this is the flow and the whole flow decimates. And there is always vertical crack between the top window and the top floor's window. Okay, the upper floors window and lower floors window. There is also cracks, obvious cracks between two windows, okay, on the same floor. This is the stadium. So for steel structure, and even it is long span, its seismic performance is usually considered to be good. Okay, good seismic performance because there is less mass, and mass will produce the initial force. Initial force will produce the damage. Okay, so if we adopt steel components, it usually have uh, good good deformation performance, good ductility, and maybe because of the less mass and the inner force is usually small. Okay, old building, a school, a school. Okay, it's very terrible.